Guys, we're going to knock out 2.1 by video. Sorry you got to watch this, but this is mostly a review lesson, so it's another good one for this anyway. We're studying functions. This whole chapter is over functions, and so the first thing we're going to cover is what even is a function. And so I do want you to read all of this because this will be something you'll see again. But I specifically want to focus on, I'm going to highlight a few things for you. A function is used to describe the dependence of one quality on another. So your height changes according to your age, or temperature changes according to the date. December's colder than July here. Cost of mailing a package is a function of weight. The heavier it is, the more it costs. The area of a circle is the function of its radius, right? The formula is pi squared. And so the bigger the radius, the bigger the area. The number of bacteria in a culture is a function of time. So the more time you have, the more those grow, et cetera, et cetera. A lot of them will be dependent on time. So whether that's like time and age, years, or like date or time, things that are affected by time are normally functions. So here you have a graph as well as these right up here. But water temperature as a function of time, and you can see it kind of goes up, levels off, goes down. Okay, so what is a function? A function is a rule, so it's like one thing you can do, and or we'll do several rules at a time, but one thing you can do to it, like square the number, or multiply by 2, or subtract 3. And this is the definition. What you need to know, maybe not in this formal way, but it's a rule that assigns each element of x in a set to exactly one element called fx. So what that means is exactly one f of x is your y. So for every x, you have exactly one y. Okay, and then you can see our independent variable is y, dependent is x. We do have what's called a machine diagram, and we're going to do these. If you put something in a machine, you get something different out of it depending on what it's supposed to do. And so we're going to input our x value, and then the machine's going to do whatever calculation the function wants to do, and our output is the f of x value or our y value. So like if I were to input, let's input x into x squared, well, you get out x squared, right? So if I inputted, let's do an actual number. If I put in 2 to this machine, I would get out 2 squared, which is 4. I could input 3, I would get out 9. You could do, I input 2 into this machine where I add 2. I can do a double machine, and then I'm going to square. Well, if I input 2 in here, I get 2 plus 2, which is 4. So now I'm inputting 4. This just says x, but it's really saying x plus 2 squared. I input this 4 squared, and I get 16. So really, this whole, it has 2 machines, but it's describing this function. First, we add 2, then we square. That's one. You will have to know how to do a machine diagram. We'll also do arrow diagrams. These look kind of like kidney beans or something. But here's my x's, and they map onto my y's. So if I take my x squared up here again with an arrow diagram, it might look like where my function is x squared. 2, I would get 4. 3, I would get 9, etc., etc. Okay. The squaring function assigns x squared to each real number. So it says plug in 3, -2, and the square root of 5. Find the domain and range of f. Draw a machine. I want you to pause and do that now. Okay, I plugged in 3, -2, and square root of 5 and got 9, 4, and 25. I want you to be familiar. This is function notation. Okay, so there's your answers to A. I'm going to come back to B. C. I drew a machine, and this time instead of putting x squared, I put square. That might make a little more sense to you. I stick in x, I get out x squared. And then I did it with just one of the numbers. I stick in 3, I get out 9. So we could do that with all of those. This is your machine. If we did an arrow, it didn't ask for, but you will have to do that. I already did this one earlier, right? Square root of 5 comes out to 25, and of course there's an infinite number that we could use, but we have these 3 that we're working with right now. Domain and range. So remember with domain, there were 2 things to look out for. one was a square root and one, or an even root, and one was a denominator. Here I have neither. I can plug in, remember domain is your x. There is any number of x I can plug in. If I plug in 200, I can square it. If I plug in negative 500, I can square it. So the domain is all real numbers. The range, on the other hand, range is your y values. What numbers can you not get out of a square? You can't get out negatives. And you can see here, I can get out any of these numbers, right? I can have 300 and solve. And if I wanted to, I could, that would be, I'm plugging in, these are my y values. So I can plug in 300. Oh, I can solve that, right? I can get the square root of 300. What if I plugged in negative 20? Can I solve that? Not and get a real number. And remember, when we're talking about domain and range, we're always talking about in the real number system. So my range here is, can I plug in 0 and get out 0? Yes, but I can't get out any numbers. So it would be that y, because this is my range, has to be greater than or equal to 0. And of course, we could write this in a different notation. Okay, it says evaluate a function. I need you to plug in. You can graph this in your calculator and use the table. You can plug in real quick, whatever, but plug in and solve these for me. Okay, all I did was plug in. This is f of x, so this is my x. I plugged in for x, and I got my f of x or my y. Hopefully you got those four. If not, let me know, but that's just plug and check. Make sure when you're squaring, you put the fraction or a negative in parentheses. If you got this in decimal form, totally okay. Hey, you remember piecewise functions from last year? A cell plan costs $39 a month. The plan includes 400 free minutes and a charge 20 cents for each additional minute. The monthly charges are a function of the number of minutes given by. Okay, so what this is saying is it says I have two equations as an option for cost. If you use within the 400 minutes, so up to being equal to 400, it is just $39 a month. But for every time or every minute you go over 400, that's going to be the 39 plus 2 cents for every, 20 cents for every minute I go over 400. So that's what the x minus 400 is. It says find 100, 400, and 480. Well, to plug in 100, I got to find which range 100 is in. 100 falls into this range. So C of 100 is going to be this equation, which is just $39. Where does 400 fall in this range? Well, this is greater than or equal to 400, so it falls here as well. But the minute you go over 400, so if I did 400.005, I would jump up to this equation. And that's what's going to happen for 480. So all you have to do is look over here at your x values, what it's limiting your x values, and that's how you decide which equation to plug it in. Then once you decide, you plug it in. So I'm going to plug in here. So you do 480 minus 400 times 0.2 plus 39. Okay, pause it and rework it. If you have any questions, let me know. I'm going to go to example 4. It says evaluate the function. So it's asking us to plug in. Well, here I have f of x. If all that happened here was x became a. Okay, done. For b, all that happened here was it became negative a. So I'm going to say 2 negative a squared plus 3 times negative a minus 1. Negative a squared is a squared, but this becomes a negative 3a. So all I did was plug in, but then I simplified. So this is A, part B. Ooh, part C, A plus H. That's okay. Everywhere I see an X, I'm going to instead plug in an A plus H. So 2 times X, but X is A plus H squared, plus 3 times X, but X is A plus H. Now simplify. So A plus H squared, you're going to want to FOIL that out. And you can take some time to do that now if you need to pause and distribute your 2 between all of that. distribute your 3. And unfortunately, not any of that cancels. So that's how we're going to leave it. And that's C. So all this is plug and chug. Now, going to pause and erase. Okay, so now we're going to do part B, and it's really long. Fortunately, we've already done the hard work for this. If you were working this as a problem by itself, you would plug in f of a plus h, then plug in a for f, then you'd have to distribute that negative and then divide by h. We already know what f of a plus h is, so I'm going to replace this with all of that, and we know what f of a is, and replace this with all of that. So f of a plus h and then if you want to at the same time distribute your negative, I'm going to subtract all of this. If you need to do it in a separate step, do it. But I change the sign to every single one. And then I still have an h on bottom. Oh, 2ah minus 2ah cancels. Oh, totally made a mistake here when I copied our answers. That should not be an x. I don't have any x's here. It should be an a. And that should have been a good clue, right? Oh, I don't see anything to match with this. Okay. Now I can cancel my negative 3a, negative 1 plus 1. So I'm left with 4ah plus 2h squared plus 3h all over h. Well, I can cancel out a h of each one to be sure. I'm going to factor out this h. We can cancel. So all this is simplifying. Simplifying like we've been doing for several chapters. And this is our answer to f of a plus h minus f of a over h. All right, 2 more. Astronaut weighs 130 pounds on the surface of Earth. Then her weight when she is h miles above the Earth is given by the function. Okay, here's my function where h is what I'm going to plug in, right? It's like my x. What is her weight when she is 100 miles above Earth? Pause and plug in. Okay, I plugged in 100. You can throw it in your calculator. I got approximately 123.67. So that is her weight in pounds. Or that is what she feels like her weight is in pounds. And then B says construct a table of values given that her weight from 0 to 100. I want you to construct this table by hundreds. Pause and do that now. Okay, so I constructed 0 to 500. I plugged in around to the 10th place. It says, what do you conclude? Okay, well, I can see it's going down, 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 down. So I conclude the higher she is away, or the higher she is, the less she weighs. You can see that pattern there. And one review and then we're done. Finding domain. So the two things we looked out for, we've already talked about this, is even roots. And remember, whatever's under the radical has to be, I'm going to say the radical has to be, it can't be negative, so greater than or equal to 0. And then you have domain. And domain, we're talking about domain. Denominator. The denominator cannot be equal to 0. Okay, so I want you to stop. This is a review and find the domain of each function. Okay, so here we have x cannot be equal to 0, x cannot be equal to 1. That's because I set my denominator equal to 0, set my even root greater than or equal to 0, and solved. But I get like 2 different answers. This is where you would test my negative 3 and 3 and pick out which ones are negative, or in this case, sorry, greater than or equal to 0, so positive. And this is what you'll get. Some of you know, remember the other way to do that as well. And then this has both. My even radical has to be greater than or equal to 0, but my whole denominator has to be not equal to 0. So here I have several different answer options, or 2 different, but. And then, so we're done. That was a quick review. But here's just a good thing. We're going to do some of this tomorrow. But how to write a function in words. Here's your equation. We might have a graph, and we might have a table. Okay, awesome job.